Alright, hello everyone. In this video we're going to talk about inequalities. Now in order to understand inequalities, we need to understand first equalities, right? Or equations, right? These are things that we've seen before, and more importantly, we've learned how to solve them, right? If I had x plus 4 is equal to 7, we know we're trying to find the value of x that when I add 4 to it, I get 7. And we developed an algorithmic process, right? Algebra skills that allowed us to solve this. And we could say, all right, well, minus 4 from both sides. And we get that x is equal to 3, right? 7 minus 4 is 3. We get that x is equal to 3. And that's all well and good. We get one finite value, one definitive value for x. But that's not always how the real world works, right? I mean, let's say Joe Schmo is applying for a job, and he would be satisfied if he makes at least $10 an hour. Or Betty would be satisfied if she pays less than $90 for her water bill this month. Those statements, at least or less than or greater than or at most, or all of these words that we use are not strict singular values, right? Because if Joe Schmo wanted to make at least $10 an hour, that means he'd be satisfied with 10, 11, 12, 13, anything bigger than or equal to 10. So there are multiple values we could find to satisfy the equation that he's making. So how do we represent that? We represent that with inequalities. And a simple example of inequalities would be something like this. Instead of saying x plus 4 is equal to 7, let's say that x plus 4 is greater than 7. This is an inequality. It means that it's not necessarily equal to one value. It's a range of values. So we're saying some number plus 4 has a sum which is bigger than 7, meaning that this sum could be 7.1, 7.2. It could be 8, it could be 9, it could be 10, it could be 1,000,000. Any of those numbers are bigger than 7. The only thing it can't be is 7 or lower, right? If x plus 4 is equal to 7, no good. We want it to be bigger than it. If it's 6, no good, we want it to be bigger. If it's 0 or any of the negatives, we don't want any of that. So, we want to solve this for the value of x and all the values of x that would satisfy this equation. How do we do that? Believe it or not, we solve it the same exact way that we would solve a regular equation. We would subtract 4 from both sides. Subtracting 4 from both sides, we get that x is greater than 3. What does that mean? That means if I plug in x equals 4, or 5, or 6, or 7, or 8, or 9, or 10, anything bigger than 3, when I add 4 to it, I'm going to get a number that's bigger than 7. And I've satisfied my inequality. That's it. That is how we work with inequalities. Now check back in for more examples because I'm going to go over some of the finer details of this because there is one exception that you need to pay attention to. There's one exception when it comes to inequalities that you need to pay special attention to in order to get these problems correct. All right? So check back in for more examples. I'll see you next time.